The allowable cable substitution for BM cable is CMP. The exposed usable length of a cord coming into the side of an RV exterior shall be a minimum of 7.5 meters. Lighting circuits operating at less than 30 volts are not to be grounded. The junction box for a no-niche luminaire operating at 15 volts or less shall be a minimum of 4 inches above the pool deck, and shall not be less than 4 inches from the inside wall of the pool. When considering cable substitutions, it's crucial to understand the specific requirements outlined in the electrical code. Cable types are designated based on their intended use and fire resistance characteristics. Substituting one cable type for another requires careful consideration to ensure the replacement cable meets or exceeds the safety standards of the original. CMP, or Communications Multipurpose Cable, is often used in plenum spaces because it is designed to limit the spread of fire and produce low smoke. BM cable, which is often a cable assembly, needs to be carefully evaluated for appropriate substitutions based on its application and the specific code requirements. The length of an RV cord is a safety consideration. Ensuring a sufficient length allows for connection to power sources without undue strain or tension on the cord or the electrical connections. A minimum length is specified to prevent hazardous situations that could arise from using extension cords or improperly connected power sources. When dealing with electrical installations in recreational vehicles, always consult the applicable electrical code for specific requirements related to cord lengths, wiring methods, and grounding. Lighting circuits operating at low voltages, specifically less than 30 volts, typically do not require grounding. This is because the risk of electric shock at these voltage levels is significantly reduced. Grounding is a safety measure intended to provide a path for fault current to flow, tripping a circuit breaker or fuse into energizing the circuit. However, at very low voltages, the potential for dangerous fault currents is minimal and grounding may not be necessary. Always refer to the electrical code for specific requirements regarding grounding of lighting circuits based on voltage levels and application. For luminaires operating at 15 volts or less near a pool, specific requirements address the placement of the junction box. The junction box must be a minimum of 4 inches above the pool deck to prevent water from entering the box and creating a shock hazard. Additionally, the junction box should be located at least 4 inches from the inside wall of the pool. This requirement helps to minimize the risk of electrical hazards associated with water and proximity to the pool. When installing electrical equipment near pools, it is essential to adhere to all applicable electrical codes and safety standards to ensure the safety of pool users. Electrical codes are regularly updated to reflect new technologies, safety concerns, and best practices. Keeping abreast of the latest code revisions is essential for electrical professionals and anyone involved in electrical installations. Understanding the rationale behind the code requirements can help to ensure that installations are not only compliant but also safe and effective. Always consult with a qualified electrician or electrical inspector if you have any questions or concerns about electrical installations or code requirements. Furthermore, consider the context of the installation. Is it residential, commercial, or industrial? Each environment may have specific interpretations or additional requirements. Also, remember that local jurisdictions may have amendments to the National Electrical Code. It's crucial to check with the local authority having jurisdiction, also known as the AHJ, to ensure compliance with all applicable regulations. The AHJ is the ultimate authority on electrical inspections and code enforcement in your specific area. Proper cable selection is critical for electrical safety and performance. Using the wrong type of cable can lead to overheating, insulation breakdown, and even fire. Always refer to the electrical code for guidance on selecting the appropriate cable type for your application, considering factors such as ampacity, voltage rating, and environmental conditions. Also, be aware of the specific markings on cables which indicate their type, size, and other important information. This information can help you ensure that you are using the correct cable for the job. Understanding the principles of grounding and bonding is essential for electrical safety. Grounding provides a path for fault current to flow back to the source, while bonding connects metal parts together to create a low impedance path for current. Both grounding and bonding help to prevent electric shock by ensuring that metal parts are at the same electrical potential. Proper grounding and bonding techniques are crucial for minimizing the risk of electrical hazards. Regularly inspect electrical equipment and wiring for signs of damage or deterioration. Look for cracked or frayed insulation, loose connections, and corrosion. Any damaged equipment should be repaired or replaced immediately to prevent potential hazards. Regular maintenance and inspection are essential for ensuring the continued safety and reliability of electrical systems. Electrical safety is a shared responsibility. Everyone should be aware of basic electrical safety practices and take precautions to prevent accidents. This includes avoiding contact with exposed wires, using ground fault circuit interrupters or GFCIs in wet locations, and never overloading electrical circuits. By following safe electrical practices, we can all help to create a safer environment. Consider the environmental conditions when selecting electrical equipment and wiring. For example, in wet or damp locations, use equipment that is rated for those conditions. In areas where there is a risk of corrosion, use corrosion-resistant materials. Choosing the right equipment for the environment can help to extend its lifespan and prevent premature failure. Always follow manufacturer's instructions when installing and using electrical equipment. The manufacturer's instructions provide important information about proper installation, operation, and maintenance. Failure to follow these instructions can lead to equipment damage, personal injury, or even fire. Therefore, take the time to read and understand the manufacturer's instructions before using any electrical equipment. When working with electrical circuits, always energize the circuit before starting any work. This means turning off the circuit breaker or removing the fuse that supplies power to the circuit. Use a voltage tester to verify that the circuit is de-energized before touching any wires or components. De-energizing the circuit is the most important step in preventing electric shock. Consider the potential for arc flash hazards when working with electrical equipment. Arc flash is a dangerous electrical explosion that can occur when there is a short circuit or other electrical fault. Arc flash can cause severe burns, blindness, and even death. Therefore, it is essential to take precautions to prevent arc flash, such as wearing appropriate personal protective equipment, or PPE, and using arc flash rated equipment. Always consult the electrical code and other applicable standards for guidance on arc flash safety. When installing electrical wiring, be sure to support the wiring properly. This means using appropriate supports, such as staples, straps, or cable ties to secure the wiring to the building structure. Properly supported wiring helps to prevent damage to the wiring and ensures that it is properly protected. Also, avoid running wiring through areas where it could be subject to physical damage, such as in attics or crawl spaces. When making electrical connections, be sure to use the correct type of connectors. This means using connectors that are rated for the wire size and type being used. Also, be sure to tighten the connections properly to ensure a good electrical connection. Loose connections can cause overheating and arcing, which can lead to fire. Therefore, it is essential to use the correct connectors and tighten them properly. If you are not comfortable working with electrical circuits, it is best to hire a qualified electrician. Electrical work can be dangerous, and it is important to have the necessary knowledge and experience to do the work safely. A qualified electrician will be able to properly install and maintain electrical systems, ensuring that they are safe and reliable. When selecting an electrician, be sure to check their credentials and references. Also, ask them about their experience with the type of electrical work that you need to have done. It is important to choose an electrician who is qualified and experienced. When planning an electrical project, be sure to obtain the necessary permits. Electrical permits are required for many types of electrical work, and they help to ensure that the work is done safely and in accordance with the electrical code. Contact your local building department to determine what permits are required for your project. Also, be sure to schedule an inspection of the work after it is completed. The electrical inspector will verify that the work was done properly and that it meets the requirements of the electrical code. Understanding the different types of electrical circuits is essential for electrical safety. There are two main types of electrical circuits: branch circuits and feeder circuits. Branch circuits supply power to individual outlets or appliances, while feeder circuits supply power to multiple branch circuits. It is important to understand the difference between these two types of circuits in order to properly size the wiring and overcurrent protection. When selecting overcurrent protection devices, such as circuit breakers or fuses, be sure to choose devices that are rated for the circuit being protected. Overcurrent protection devices are designed to protect electrical circuits from overloads and short circuits. If the current in a circuit exceeds the rating of the overcurrent protection device, the device will trip, interrupting the flow of current and preventing damage to the circuit. Therefore, it is essential to choose overcurrent protection devices that are properly sized for the circuit being protected. Understanding the principles of electrical theory is essential for electrical safety and troubleshooting. Electrical theory provides a framework for understanding how electrical circuits work and how to diagnose problems. Key concepts in electrical theory include voltage, current, resistance, and power. By understanding these concepts, you can better understand how electrical circuits function and how to troubleshoot problems. When troubleshooting electrical problems, it is important to follow a systematic approach. This means starting by identifying the symptoms of the problem and then using a process of elimination to narrow down the possible causes. Once you have identified the cause of the problem, you can then take steps to correct it. Always use caution when troubleshooting electrical problems, and be sure to energize the circuit before starting any work. Understanding the specific requirements for different types of electrical equipment is essential for electrical safety. For example, appliances, lighting fixtures, and motors all have specific requirements for wiring, grounding, and overcurrent protection. It is important to understand these requirements in order to properly install and maintain the equipment. Also, be sure to follow the manufacturer's instructions when installing and using electrical equipment. When working with electrical equipment, be sure to wear appropriate personal protective equipment, or PPE. This may include safety glasses, gloves, and a hard hat. PPE helps to protect you from electrical hazards such as electric shock, arc flash, and burns. Always inspect your PPE before using it to make sure that it is in good condition. Also, be sure to use the correct type of PPE for the job being performed. Maintaining a safe work environment is essential for electrical safety. This means keeping the work area clean and free of clutter, providing adequate lighting, and ensuring that there is proper ventilation. Also, be sure to follow safe work practices such as using lockout-tagout procedures and avoiding working alone. By maintaining a safe work environment, you can reduce the risk of electrical accidents. Always be aware of your surroundings when working with electrical circuits. This means being aware of potential hazards such as overhead power lines, buried cables, and other electrical equipment. Also, be sure to keep a safe distance from these hazards. If you are working near overhead power lines, be sure to maintain the minimum safe clearance distance specified by the electrical code. Understanding the specific requirements for different types of occupancies is essential for electrical safety. For example, hospitals, schools, and factories all have specific requirements for electrical systems. These requirements are designed to protect the occupants of these buildings from electrical hazards. It is important to understand these requirements in order to properly design, install, and maintain electrical systems in these occupancies. When working with electrical circuits, always use caution and common sense. Electrical work can be dangerous, and it is important to take the necessary precautions to prevent accidents. If you are not sure how to do something, it is best to consult with a qualified electrician. By following safe electrical practices, we can all help to create a safer environment. And remember, consult local and national electrical codes and regulations for definitive guidance.